Well, hey there, fourth grade scientists. Here we are again. If you've been keeping up with your work, then today we're going to be taking a look at worksheet page 16 titled Circuits. Like the last couple times, I'll read through it and then we'll take a look at some answers and see how we do. And as always, if you have any questions, please be sure you let me know. All right, circuits. An electric current needs two P's to flow, a push and a path. The push is a source of electricity that makes electrons move. For example, a push can come from the chemical reactions in a battery or from a generator whose magnet causes the electrons to flow. Second paragraph. The path electricity follows is called a circuit. The path is made of conductors that allow a current of electricity to flow. The path or circuit allows electricity to flow from a power source to devices that use electricity such as light bulbs, fans, and motors. A circuit's path can be open or closed. In order for electricity to flow, a circuit must be closed, meaning all parts of the circuit are connected and unbroken. Electricity cannot flow through an open circuit because in an open circuit, the path is incomplete. When you turn on a light switch in your home, you are closing a circuit and allowing electricity to flow. When the light switch is off, the path is open and electricity cannot flow. All right, so there's the basics of what a circuit is. Let's go down the bottom here. Question number 1 says, match each of the following statements to whether they are best answered by paragraph 1, 2, or 3 of the text. I think we've done this a few times before already this year. So, number 1A, what causes electricity to flow? That has got to be paragraph number 1. If you go back up to paragraph 1, look at the second sentence here. It starts with a push right there. A push is a source of electricity that makes electrons move. That's what causes the electrons to flow. There is a push. There's a source of that energy. There we go. So 1B. How can electricity be turned on and off? Well, look at paragraph 3 here. A circuit's path can be opened or closed, like when you turn on a light switch. That's how you open and close a circuit. You turn it on, you turn it off. That's a switch. So paragraph 3. And the last one here on number 1C says, what allows electricity to move? Well, we know electricity can't flow unless it has there's that word right in the middle there, path. Electricity needs a path to flow. If there is no flow, electricity is not moving. So there you go. 1A is paragraph 1. 1B is paragraph 3. And 1C is paragraph 2. Moving on to question number 2. Label the push and then label the path in the diagram. So right over here we have a simple battery with a light bulb circuit. The push, that's the source, that comes from the battery. And the path is represented by that line, and those would obviously be the wires that connect the battery to the light bulb. So the line is the path, and the battery is the push. Question number 3 down here. Explain how you could interrupt the flow of electricity from the battery to the light shown in the diagram. So if you go back to our diagram, if everything is connected the way it shows here, that light bulb is going to be constantly lit up until the battery is out of energy. So the question says, how could you interrupt that flow? What could you do to stop the flow of electrons from the battery through the light bulb and then back to the battery? Well, how about this? Add a switch. Kind of like a light switch. On, off, on, off. That's one way to interrupt the flow. Adding a switch. And for the last one, for each situation, determine if the circuit is opened or closed. Remember, if the circuit is open, there is no path for the electricity to flow. And if it's closed, that means the path is complete Electricity is flowing. A, you press the power button and the TV turns on. Hey, if the TV turns on, everything's working fine. That would be C, closed. B, you turn the light on, but nothing happens. A bulb is broken. If you've got a broken bulb, then there's no way the electricity is going to flow from the source through the bulb and then back to the source again. The bulb is broken. That breaks the path. That makes it open. That's not going to work. And the last one. Before fixing the electric wires in your home, the electrician turns the electricity off at the electrical breaker. That's usually a box, sometimes in your basement or somewhere in your house. And if you turn off the right switch, no electricity is even going to flow to a certain room. And if you're working on the electricity, you don't want any electricity flowing to those wires while you're touching them and working on them. So if you turn off the breaker, no electricity is going to flow there, and that's a good thing. But if no electricity is flowing, that means the circuit is open. So there are your answers for number 4. A is closed, B and C are both open.